So thanks guys for joining us. Yeah, and absolutely. So I'm certainly rely on Mitch for a lot of technical expertise. He's been collecting survey and ground control points for Compass data for almost 10 years. He's got a lot of time in the field. His understanding of geodesy and survey workflow processes are top notch. So when it comes to the survey projects that we work on, his technical expertise is super valuable to me when I talk to my customers and working with clients. So I couldn't have put this presentation without Mitch's help together, so make sure if you guys have a question, come up and ask us afterwards. So we got a couple of objectives in this presentation we're going to run through. I think Randall stepped out, but we just want to thank DJI for inviting us an opportunity to speak. So some of the things we're going to go through today is we're going to have a little agenda. So we're going to talk about kind of who we are, what CompassDrone is, what's it made up, what we do in the industry. We're going to talk about accuracy validation processes that we use. We're going to talk about the accuracy standards that we follow and how we deliver imagery, photogrammetric products to our customers. And we're going to go into the details of three kind of case studies when it comes to absolute relative accuracy, kind of what we use in our process. And just going to talk a little bit about golf is a company that we've been working with very closely. We're going to talk about some of our surface modeling procedures and what we do when it comes to creating digital elevation models, orthos, 3D models. And then we're going to wrap up with what we've been working in law enforcement with critical investigation and mapping processes for critical event mapping, we're calling it. We don't have an official term for the product yet. We're bundling it, but we're still in the working phase. So there's a production movie company called Working Title. I think it's a really good name of a production company. Yeah. Just finalize that. Never do anything else. So one of the things today is, I don't know if any of you are opera fans in the audience, but there's a term in opera called leitmotif, and they use it in Star Wars. That theme music that you hear every time Darth Vader walks into a room, that's called a leitmotif. It's a reoccurring thematic musical interlude to let you know what's happening. So in this world, we have realized that there's a couple really consistent themes with what we're doing. We're saving companies time. We're providing them accuracy validation. We're working in consistent industry standards that they're expecting that they use. And safety is obviously is paramount. So in the presentations yesterday, when it was a slide of a guy climbing down the side of a rock wall, we're talking about saving lives. Very important workflow. When it comes to accuracy, that's where we really specialize. So you will see these thematic notes throughout the entire presentation. So dive into it. Let's get started. So who we are. We are CompassDrone. That's the headline. That's who's been invited. That's the DJI partner. CompassDrone is made up of the expertise of a couple of Compass organizations, notably Compass Tools, which has been a Trimble navigation business partner for 20 plus years. We're expertise in ground control, survey, mapping, data collection techniques. We understand what it takes to process GPS data and put it into existing models and workflows. Compass Data, so they are the world's largest commercial ground control archive company. Approximately over 45,000 ground control points right now. They provide these ground control points to satellite imagery and aerial providers. So when it comes to the LiDAR programs, the 3-depth, there's a couple different programs that collect mass amounts of data. They use Compass Data's processes and points to validate that. So the affectionate term for and there's some marketing material, and I loved it. I don't know, we don't use it enough anymore, but they used to call the Compass Data survey team control freaks. And I love that term because they are just massively invested in the survey point, and it's a really affectionate term for those guys out there in the field. So how did they get this term? How do they get this knowledge? Well, they have validation procedures. We have SOPs, standard operating data collection processes. On our staff, we have geodesists, we have certified photogrammetrists, we have people that understand accuracy validation, data processing. We understand how to stand that data up and how to validate it. And then when it comes to sort of the products we deliver and some of our customers, we have a DO200 certification process. We're ISO certified in the data processing. And that's critical for a lot of our large customers, our federal agencies that need the data to be stood up and validated by the processes that we use every day. The reason that companies like Digital Globe, Airbus, Hexagon, Voltus, they use our ground control to process their satellite imagery is because of an understanding that we have when it comes to processing and accurately validating that imagery. So how do we get there? How do we get these companies? How do we get processes? Well, we didn't make it up. We're not the ones that are writing the guidelines. We follow the industry standards. ASPRS is the American Society of Photogrammetry and Remote Sensing principles. This is an organization of geodesists and photogrammetrists that intimately understand the processes of data collection with imagery. They set guidelines out. They're very strict and very detailed guidelines on what it is to take imagery and process it. This is directly from their website. They're the leading scientific and professional organization representing photogrammetry and remote sensing profession. The guidelines below represent the best efforts ASPRS at defining and clarifying key issues that affect the procurement of professional geospatial mapping services and commercial geospatial mapping products. So this group comes up with standards for how imagery off of a satellite, off of a plane, off of a helicopter, how it's processed, validated, and delivered into a finalized professional product. On the UAS projects that we work on, when we do service collections for our clients, we follow the aerial imaging checkpoint guidelines because that's the best that we can do. If we have a customer, they expect us to deliver this product to them that meets very, very high standards. I want to highlight this point right here that the recommended number of checkpoints based on area today for a size less than 500 square kilometers is 20 checkpoints. Now, I've sat in a lot of presentations today, and I've talked to a lot of folks about ground control and orthorectifying the image. I have not heard anybody say checkpoint. So a checkpoint is a GPS known location in the image that's not used in the orthorectification process. It's independent from the ground control. Critical to validating the accuracy of the image you're providing. So I just want to highlight that because it's 20. That's quite a bit. I mean, when we send surveyors, we send folks to go on UAS projects. They're there for a half a day collecting GPS points for the images and the products we're producing. So a little bit further into that, if you guys are interested, I just grabbed a couple slides about trying to understand distortion and photogrammetric products. So these are two slides that I grabbed that I really like. So this one sort of, the idea is that a camera system, you're attempting to two-dimensionally represent on an image a three-dimensional undulating surface. And there can be distortion in the camera system as well as the ground. One of the best stories I heard from a long, long time ago, aerial photography and military and data collection has been a part of our operations in the armed services for a long, long time. When we are looking to analyze images coming off of airplanes, we have to understand that the camera system on the plane, when it's sitting on the tarmac on a summer day and it's 100 degrees out, the lenses, the pixels, the camera system is acclimated to the temperature on the runway. When that plane takes off and gets up into the atmosphere and it's negative 20 degrees, what do you think it's doing to the optics of the camera? It's probably distorting them very, very minutely. But if you're in a system in the air taking imagery to the ground, little slight distortions in the camera system on the airframe are going to be magnified when you're taking that picture of something on the ground. So it's not that the distortion exists. We all are, in the industry, we're fine with the distortion. We just need to be able to quantify and measure and understand how much distortion there is, where it is, so that we can adapt to it and change and consume the product. Oh, am I going backwards here? So in that same discussion, we like to have this difference, understanding the difference between accuracy and precision. They are two different terms, and they mean two different things. When you talk about something being accurate and precise, you have this example here in the radical with the crosshairs. When you talk about something being not accurate but precise, this is sort of a visualization of that. So also in a lot of the discussions today, they've been talking about RTK systems, the centimeter grade accuracy of the DJI platform. All well and good. It's great that the system is in spatially where we want it to be. But the position of the airframe when it takes the picture is not relative to the image and where it is in an absolute accuracy. They're two different things. So a centimeter grade precision of the rotocopter has nothing to do with where the image is going to be in space. So the precision and accuracy, I just want you guys to understand that. Oh, and there's the system precision. So this is a good point to also bring up the terms relative and absolute accuracy. For a lot of applications, relative accuracy is fine. It's what we need. It's all we need. But absolute accuracy for a lot of our customers, when it comes to ingesting the aerial imaging into engineering firms, construction firms, large data collections, local coordinate systems, local projection systems, they need the data to fit into what they use. So relative data to them doesn't help them out. So let's go into accuracy validation steps. So we obviously identify a problem, and that's where Compass comes in. We have a solution for it. So we actually have two products, proprietary software products called Compass AA and TA. They're accuracy validation, automated accuracy validation processes. What we're getting out of those is we're inputting data, we're inputting our checkpoints, inputting our ground control and our image, and what we get spit out is a report about the imagery and where the imagery fits in a confidence level. So we're never going to see imagery come off of any system and be 100% confident that every single pixel is exactly where we want it to be in the world. But what engineers use is a standard called CE95. It's a confidence level that the imagery. So when we generate this report, and one of my colleagues at my office came into me and said, there's only one thing that engineers care about, and they see this. It's this line, and it tells you the confidence level that 95% of the pixels in this image are within this spacing. It's the only thing that matters to them. So along with that, we import these checkpoints, and I have a couple sample reports if people want to see them. They can kind of see what they look like. But checkpoints get entered, and it's a lengthy report. It shows every single point in the image, its latitude, its longitude, where it is in space. We understand the delta change between the checkpoint where we think it is in the image and where we can see it. So it's measuring that distance change. And oftentimes it's slight shifts, it's slight distortion. We're not talking massive issues. But engineers and large firms and the standard body that measures how photogrammetry products are processed and validated need to know exactly what the error and distortion in the image is. So it's not good enough to say, it's close enough, pretty sure it's accurate, it looks good. That doesn't fly in engineering. Well, I don't know how many of you guys know engineers with PEs, but good enough doesn't really cut mustard. So we have another product, the TA product. It's very similar to AA. It's topo analysis. It's doing the same thing on the X and Y as it does on the Z. So we're talking about the vertical measurement and its accuracy level. When DJI approached us, we're a hardware seller for DJI. When we sell bundles, it includes GPS equipment, training on the survey and mapping equipment, and the DJI system. Because to us, it's a bundle package. Understanding GPS data collection and integrating it into the image collection process they're one and the same. They're integral. If you want to have a product delivered into a professional workflow, if you're going to take video of your son skateboarding down the street, you don't need GPS, right? But if you want to integrate it into GIS systems, AutoCAD, engineering, you want to put it into existing workflows, it's a critical part to that workflow. So the bundles on our site and everything we put together for our customers include high-level survey mapping equipment, GIS and mapping level equipment, all kinds of different mix and match of the equipment. We decided to change around our terminologies. Volumetrics, measuring piles, that's sort of what we see marketing material online, volumetrics is the buzzword, but it's really surface modeling, understanding change of what is the bare surface underneath that pile, how does it go up and down. So we're kind of working with the surface modeling terminology. And so when it comes to different types of collections, Mitch mentioned we have landslides, we have aggregate companies, mining, we have lots of different types of people that need surface modeling. And what is their main objective when they're doing this surface modeling? So they use currently survey teams to deploy on piles or collect information about that site. But what they really would like is to save time and money on the collection of that data. So a traditional workflow represents, typically we talk in the 50 post spacing. That's sort of a term that we use and surveyors use a lot. So they're walking a field or they're walking a pile, taking survey equipment, going every 50 feet and collecting GPS data about that point. A safety concern from a laser measurement perspective is that oftentimes you have to either close access to the pile or deploy the team to climb on the pile to collect that data, which means operations have to either be paused or halted. What we're kind of talking about here is generating these products like 1-foot contour lines, digital elevation models, and the imagery. Now, these are all products that a manager or site project manager or site operations chief would absolutely love. They're geospatial data products. They're awesome. They look great. But in order for them to fit into their system, there's a couple extra things that we ought to do. And today we've talked a lot, and I've heard a lot of presentations of different products that take imagery off a drone. And, well, you know, the complete solution really is more than just a pretty picture. So I have Brandon to thank for this slide. This is a sign outside the Aspen Art Museum in Colorado. And I'm a geo geek. I love looking at satellite imagery and exploring around the world. But, you know, looking at a pretty picture really doesn't just do it all. So matching local coordinate systems, critical part of the final product fitting into a real workflow. Understanding projection systems, understanding data transformations, geoids, sea level, datums, epochs. These are all terms we use all the time when we're processing data. These are terms in the geospatial industry that come up every day in our office multiple times. So I got to move a little quicker because we're running out of time. But here I just wanted to highlight. So this is a land developer in Texas that we were working with, and this was their 50 post spacing. And was this a local coordinate system? The engineer there or the surveyor? Yeah. So here's his model. This is what the data they had. So on this case study, we took an Inspire and we flew it, and we were able to collect data at a much, much higher level and a much better accuracy. So you can see every one of these purple X's is the elevation model that we were able to collect from the Inspire with our checkpoints and our ground control. And we had to dumb it down because they couldn't ingest the amount of data. So if you understand how much you're losing, and then the customer can say, I can tolerate this, I can't tolerate this. But if you just are compressing and distorting, and then you say, you know, the resolution's not as good. The engineer's going to ask, how not as good? So about golf, what they do is they make golf simulators. They make very accurate golfing simulating experiences. And what they're doing is, if you guys remember, I don't know if you guys remember this game, particularly from the mid-90s, I do. It was a software program by Microsoft to come up with a mapping, a model for a golf course. And that's what it looked like, and it wasn't very realistic. Well, they've gotten a lot better. And as an organization, their objective is to create a very, very accurate representation of a golfing experience. So in their traditional workflow, what they do is they deploy people with GPS backpacks to a golf course to walk it. It takes 2 to 3 days. They walk around every putting green, every sand trap, and they're collecting about 300 to 500 GPS points on a golf hole, bringing that data back into the office and interpolating between those points. So when we approach our relationships with About Golf, we said, hey, you know, we could probably go to this course and we can fly it in a day, generate a very dense point cloud, which you can either put to whatever level you want and ingest it into a modeling system. So in addition to the points, we're getting RGB photo, realistic representation of what's there at the course. And some of the numbers that came off of Hazeltine, I don't know how big golfers you guys are, but Hazeltine's where the Ryder Cup was this year. It was a pretty famous and a very, very important course in the US. We did an assessment, and we got 360 points per cubic meter to deliver to About Golf for their modeling. So what they get is an extraordinarily accurate grid for creating a surface model, and they loved it. So this is an important distinction I want to make. So before, when they talk about, so you're getting a three-dimensional elevation, right? So you understand the heights of these trees and these grasses, and if this is a tee box and you're teeing off here, or your ball flight, and part of the realistic model before, they would just estimate the tree heights in the model because they didn't actually have a measurement. Now, when we're flying it, we're delivering these, and they're able to incorporate them to actually have a completely accurate model of all the heights and the vertical parts that make up a golf course. So we're also at some of the clubhouses on the courses. This is also an important thing. We're not using this for engineering and architecture grade levels, but they do want this experience of the clubhouse on the course to fit to scale and be a model of what's actually there. Clubhouses at a lot of these courses are very important parts of the experience of going to the course. So we have a bunch of relationships with different law enforcement agencies and like a little consortium of some sheriff's departments we're working with. It's nothing new that accident mapping and law enforcement agencies want to use drones. It's old hat. There's marketing material for 2 years on the web. You can go online and find other companies promoting it. Why they came to us is because of our ISO, our certification processes, how data is being ingested and analyzed. It's not that they don't want to use the equipment. It's that they need to be certified. They need to document maintenance logs. They need to document training. It's all the policies and procedures of use of the equipment. For them, it's a tool. And the best analogy I can give you for what they worked with 10 years ago was the TASER system. TASER was successfully adopted by so many agencies because of the policies, procedures, training, maintenance, all of the use function of the tool was documented. That's why it became the mainstay in the law enforcement community. Right now, today, how they do data collection is they have total stations. They have two $150,000 laser scanning systems they deploy on site, and they're super accurate and they're awesome. But not every accident that occurs or scene that needs to be documented from a legal standpoint needs the use of that laser system. It takes a long time. It takes an operator that's trained and knowledgeable on the system. They have to close the road. It's a huge pain in their butt. The accident mapping software that they use typically just simply needs measurements to put into it to calculate, to spit out what they're looking for. So they need to be able to measure distances and be confident in those distances. So the interesting scenarios that we've been working with them are not only the use of a drone, but also an Osmo handheld, because we're doing some really cool 3D modeling and measuring with just an Osmo. Unfortunately, so we're not really allowed to actually show a bunch of the pictures that we've been working with because technically they're involved in current litigation and legal cases. So we kind of degraded a couple of them. That's a link to a sheriff's department in Georgia that used a Phantom video. We don't have time to play it. We're doing what other folks are doing. We're doing 3D modeling. It's nothing special. Again, I just want to emphasize that it's not the capability of the equipment that's holding back the adoption of it. It's the validation accuracy. It's the policies, the procedures. All these guys want to use it. We just have to kind of figure out how we're validating it. And one thing that I was going to ask of the community is, we need a couple wins. We need legal precedent in a court case. We need to find somebody using a photogrammetry solution in a legal case. And I think it'll really expand and open up that arena for a lot of us.